A continuation for solving multi-step equations. Remember the process for solving multi-steps. If there's distributive property or if there's parentheses in the equation, you'll need to do the distributive property first. And that is where you take the number on the outside of the parentheses and multiply it to everything inside. The next step is to combine like terms. So when you have multiple of the same variable on the same side of the equal sign, you're simply going to combine like terms by taking their coefficients and adding or subtracting. So like terms, you'll have it on the same side of the equal sign. The next step is if variables are on opposite sides of the equal sign, you're going to need to get them to one side. And whenever you move from one side of the equal sign to the other, you have to do the opposite to get them together. And once you've done these three steps, you'll either have a two-step or a one-step equation to solve. So when you have a two-step equation, the first thing you're going to undo is the addition or subtraction, and then you'll deal with what's attached to the variable, whether it's multiplication or division. So then you're going to undo that. So here's a multi-step example. So you notice here I have multiple things going on both sides of the equal sign. You don't want to start moving until you clean things up. So in this case, the first thing I want to do is combine like terms. Now the like terms are on the same side of the equal sign. So on the left-hand side, I see I have the like terms of 4x and the minus 2x. So I'm going to combine them. I'm going to end up with 2x minus 5. And then on the right hand of this equation, I see I have like terms that are constants. So in this case, I want to get that 4 and that plus 3 together, and I'm going to end up with 7 plus 6x. So before you do any movement, you want to clean up each side by combining like terms in this case. At this point, you see that you have variables on opposite sides of the equal sign. When you have variables on opposite sides, you need to move to get them together. And whenever you move, you need to do the opposite. I chose, in this case, to move the 6x over to the 2x. And because it's plus 6x, I need to subtract 6x from both sides. Now I'm left with a negative 4x minus 5 equals 7. And now you have a two-step equation. You're going to undo that minus by adding 5 to both sides, and then you're going to deal with what's attached. You have a negative 4x equals 12. You need to divide through by a negative 4. The opposite of multiplication is division, and you're left with x equals a negative 3. Pause and try. So you're going to combine like terms on each side of the equal sign. I end up with 7x minus 2x is going to give me 5x minus 3. And then you see I have 2 plus 8 is going to give me 10 minus 8x. And now you're going to get the variables to one side of the equal sign. I chose to move the 8x over to the 5x. I had to add 8x to both sides. And then I'm left with 13x minus 3 equals 10. I'm going to add 3 to both sides. I'm going to be left with 13x equals 13. Divide through by 13, and you get x equals 1. This next example has parentheses, which is the distributive property, and then you also have multiple terms on each side of the equal sign. So the first thing you want to do is the distributive property. Be very careful when you have multi-step equations that you distribute properly. Make sure that that number that's on the outside of the parentheses gets multiplied to everything inside. So in this case, I ended up with 10x minus 12 minus 3x equals. And then I'm going to have that 4, and I'm going to distribute it to the x and the 12. I end up with 4x plus 48 minus 9x. Now I need to do the combined like terms. Remember, combined like terms are on the same side of the equal sign. So on the left-hand side, I'm combining the 10x and the minus 3x, and I'm going to be left with 7x minus 12. On the right-hand side, I have 4x minus 9x. 4x minus 9x is going to give me a minus 5x plus 48. And now I want to get the variables to one side of the equal sign. So I'm going to move that negative 5x over to the 7x, and I'm doing the opposite, so I'm adding 5x to both sides. I'm left with 12x minus 12 equals 48. Now I have a two-step equation. I'm going to get rid of the plus or minus here. In this case, it's minus 12. I'm adding 12 to both sides, and now I'm going to divide through by 12, and I'm going to get my solution, x equals 5. Pause and try. So you have to be careful here because in this case you're distributing a negative 5. I know it's minus 5 parentheses, but that really means it's a negative 5 that's being distributed. So I have 2 minus 5x minus 25. So it's very important that you multiply correctly with the distributive property. And you're going to be left with, on the right hand side, 3x minus 6 minus 1. Now you're going to combine like terms. So you end up with 2 minus 25. That's going to give you a negative 23. So you have minus 5x minus 23 equals, and then you're going to combine that. Negative 6 minus 1 is going to give you 3x minus 7. Now you want to get the variables together. In this case, I chose to move the minus 5x over to the right hand side. It doesn't matter if you chose to move the 3x over to the 5x, minus 5x. So I chose to move the minus 5x, so I have to add it to both sides. I'm left with the negative 23 equals 8x minus 7. Then I'm going to add 7 to both sides. I'm left with negative 16 equals 8x. Divide through by 8, and you get x equals a negative 2. So this next example is a special case. So I'm going to show you what makes it a special case. The first thing I'm going to do is the distributive property. So I distribute that 7 to that x minus 3, and I get 4 plus 7x minus 21. On the left-hand side, I didn't need to do any work. Now I need to combine like terms. So the like terms is going to be that 4 minus 21, which gives me a negative 17. Now notice here, I have to get the variables to one side of the equal sign. But when I do that, I'm subtracting 7x from both sides. What's going to happen to the variable? It's going to go away, and I'm going to be left with negative 17 equals a negative 17. Well, here is a case where we need the solution for the variable, but the variable is eliminated. So then you need to make a decision based on what is left. What does that variable equal? Well, when we have the variable eliminated and the same thing equals the same thing is left. So in this case, I have negative 17. It equals negative 17. It's a true statement. Well, what that means is I have infinite solutions. I can put any value into x for the original equation, and it will always be true, which means my solution for this equation is any number. So infinite many solutions, you could say all real numbers, but in this case, when the variable's eliminated and it is equal to each other, it's the same thing, it's a true statement, then it's any solution. So now let's do another special case. I'm going to follow the steps of multi-step equations. I'm going to do the distributive property here. I'm going to combine like terms. Now notice here, when I get the variables together, I have to subtract 7x from both sides. The variable is going to be eliminated. And then you're going to be left with 8 equals 11. Well, hopefully in your mind you're saying, well, 8 doesn't equal 11. That doesn't make sense. So when the variable's eliminated and the number doesn't equal whatever's on the other side of the equal sign, then there's not going to be a solution. I'm never going to find a value for the variable that's going to make it true. So in this case, you would just say no solution or empty set, meaning nothing in the set of numbers. So when the variable's eliminated and you're left with something that's not a true statement, then you end up with no solution. Pause and try. You combine like terms, you do the distributive property, then you need to combine like terms on the right. You get the variables together and you're left with this. A -9 equals a -17. The variable was eliminated. Now you need to make a decision. This is no solution because -9 does not equal a -17. No solution, or you could state empty set. Pause and try. You do the distributive property, you combine like terms here. When you get the variables together, they are eliminated, so you're ending up with a -10 equals a -10. That's true. It's a true statement, therefore it's infinite solutions or all real numbers. So this next case, I like to single this type of problem out, but because people sometimes get confused on what to do. Well, what I need you to understand first is that top part is all together. That is an expression. And this line here, I hope at this point you recognize it as division. So that top part is all being divided by that 3. So before I can get to the variable, I'm going to need to remove that division. And the inverse of division is multiplication. So you're going to multiply both sides by 3. Now I want to be clear here. You're getting rid of that division by multiplying both sides by 3. So that 3 on the left-hand side gets canceled out. You're not distributing it. It goes away. But you need to make sure you multiply the other side by that 3 also. So it's very important that you don't miss that step. And then you have a two-step equation. You're going to subtract 1 from both sides, and then you divide through by 2, and you get your solution. Pause and try. So in this case, the first thing you're going to do is multiply by 5 to get rid of that division. Then you have a two-step equation. Make sure you multiply that 4 by 5 also. So that's where the 20 is coming from. And then you're going to add 3 to both sides, divide through by 2. And notice here you end up with the fraction as a solution. I want to be clear that we do get fractions as answers. Leave it as an improper number. That works in algebra. This next example is an equation that has multiple fractions. Whenever you have something that looks like this, the easiest way is to eliminate the fractions. And to eliminate the fractions, you want to multiply by the least common multiple. So you look at the denominators here and you say, okay, what's my least common multiple for 5, 3, and 15? Now remember, the least common multiple is the number that can divide in evenly into each number. So in this case, 15 is the least common multiple because 15 can divide into 15. But 15 doesn't divide into 3 and 15 doesn't divide into 5. So it has to be the least common multiple where each number divides in evenly into the number. So now what you're going to do, you found the least common multiple and you're going to multiply it to each piece of this equation. So you're going to multiply to the first piece. I multiply 15 to 2x over 5. Now this is a whole number being multiplied to a fraction. So this is where the multiplication of fractions come into play. Take that whole number, put it over 1. Now remember, multiplication of fractions, you want to simplify first and then multiply across. So you're going to multiply, you're going to simplify here. 5 goes into 5 once. 5 goes into 15 3 times. So you're left with 3 times 2x. You multiply 3 to 2x and you end up with 6x. You're going to do this to each piece of the equation. You're going to take that 15, you're going to multiply it to that minus x over 3, and now you have x over 3, which is a fraction. I'm going to take that 15, put it over 1, and then we're going to simplify. 3 goes into 15 5 times. 5 times x is going to give you that minus 5x. And you're going to multiply it to that last piece. So you're going to end up with 7 over 15. Put the 15 over 1. Simplify. Multiply across. 7 times 1 is simply 7. Now you got rid of all the denominators. You got rid of all those fractions. You still have to solve. And in this case, you have to combine like terms. Now notice when you combine like terms here, 6 minus 5 is simply going to be x. So you get x equals 7. So you want to get rid of the fractions and then solve. So to get rid of the fractions, you need to find the least common multiple and multiply to each piece. Sometimes it's easier to just have the number written next to each piece and then the least common multiple written next to each piece and simplify piece by piece. Pause and try. So let's just start off here with what's the least common multiple? Well, the least common multiple here is going to be 35. So I like to just simply write the 35 next to each piece that I'm multiplying it to. So now I know that I'm going to simplify piece by piece. So now I'm going to simplify. 7 goes into 35 5 times. 5 times 2 is going to be 10, so I'm going to end up with 10x. And then I'm going to simplify the next piece. 5 goes into 35 7 times. 7 times 3 is going to give me a minus 21x. And then the last piece, 35 goes into 35 once, so you're left with equals 11. And now you combine like terms here. When you combine, you end up with a negative 11x equals 11. You divide through by a negative 11, you end up with a negative 1 as your solution.